Okay, honors, this is concept 54, law of sines. This first part here may be reviewed. It should have been covered last year, but if it wasn't, you'll see that it's not, at least hopefully not too bad. I tried shooting this video already. This is actually my second take. I was taking way too long with the calculations, so I just went ahead and started all over, and now I have the calculations here to the side just to save time. So just pause the video as we go through in case I'm going too fast. So we're gonna take something here for granted. We're not gonna show where it comes from. We just don't do that here. But again, it should have been introduced last year, but we'll see. Here's the law of sines. It's like a formula, and it's very plug and play. You got sine of angle A over its opposite side A, and I'm reading according to this triangle here. So sine of angle A over opposite side A is equal to sine of angle B over opposite side B. It's equal to sine of angle C over opposite side C. So the law of sines can be used to find the side and angle measures given two angles on any side. That's angle angle side or angle side angle, or two side lengths and an angle outside of them, side side angle. So the neat thing about law of sines is that this can be applied to any triangle. It's not just right triangles like with SOHCAHTOA. So this applies to any triangle. And there's another one, which is the next concept, but you'll see how neat this works out. So it says find each missing measure, round all answers to the nearest tenth. So here I have this triangle with two given angles, and we have to find one side length here. So the sine of 34 degrees over 10, the opposite side, would be equal to sine of 52 right here, which is equal to its opposite side, x. So from here, you would just solve for x. You'd multiply both sides by x and then multiply both sides by 10, and you get this expression here. X times sine of 34 is equal to 10 times sine of 52. And then divide both sides by sine of 34, you get x is equal to 10 times sine of 52 over sine of 34. Put all this in your calculators, and just careful with your parentheses just so it doesn't read some value incorrectly, but you should get that x is equal to 14.1. so that's your side here. For the second one, same thing. You got 21 degrees here opposite to side 7, so then the sine of 21 over 7 is equal to the sine of 119 over x. Similarly, multiply both sides by x and then multiply both sides by 7. You're going to get that x is equal to, whoops, no, sorry, skipping a step there, x times sine of 21 is equal to 7 times sine of 119. Then you would divide both sides by sine 21. You get 7 times sine of 119 over sine of 21, and then put that in your calculator. You're going to get 17.1. For the third one, same thing, right? You'd have sine of 64 over 32. That's equal to well, this one's actually a little different, right? So to take this side here, I would need to find this angle here, and then if I I know that all angles inside a triangle add up to 180, so I could do 180 minus 64 minus 45, and then when you do that, you're gonna get let me see, so 71 degrees. I actually did this one wrong in my calculations here, so let's see, you get 71 degrees, then that's equal to sine of 71 over x. And then you get x times sine of 64 is equal to 32 times sine of 71. And then you get x is equal to 32 times sine of 71 over sine of 64. And then put that in your calculators. You're going to get, 64. You're gonna get 33.7. and that's all there is to it. Next one, gee, I did this one incorrect too. So you have to find the missing angle measure there, so you could take this side here. So then 180 minus 110 and then minus 41, you're going to get 29 degrees. So this one's 29 degrees. And then you can do sine of 110 over 41 is equal to sine of 29 over, did I mess this up? 110, yeah, this is not 110, this is x. Sine of 110 over x is equal to sine of 29 over 19. So then, yeah, same thing, right? So you get 19 times sine of 110, that's equal to x times sine of 29, and I'm getting 19 times sine of 110 over sine of 29. Then you should get I'm getting 36.8. So whoops, so x is equal to 36.8. That's it. So maybe you might be thinking, so why does the formula here have three ratios all equal to each other? That's because you might have a problem that has multiple missing measures that you need to find, hence all three are here. So I think all this entire worksheet only has two, but for future reference, yeah, you can use all three to find all the sides, and you'll see angles as well of a triangle. So it says for questions 5 and 6, Kevin, Adam, and Dan are passing the hockey puck, so we're using this figure that's right here. And it says for how far is Kevin from Adam? So maybe the first thing we want to do is just find what this angle is here. So 180 minus 71 minus 86. You're going to find that this one here is 23 degrees. So first question, how far is Kevin from Adam? So here's Kevin, here's Adam. So we're going to call that side there x. And I have the sine of 86 over 25 is equal to the sine of 23 over x. So I got x times sine of 86 is equal to 25 times sine of 23. That's equal to x is equal to 25 times sine of 23 over sine of 86. And put this in your calculator. You're going to get x is equal to 9.8. Whoops, forgot my unit of measurement. Feet, right? Yeah. So 6 says, how far is Dan from Kevin? Here's Dan, here's Kevin, so I have y there, and I have and it's the same ratio. You can actually, now that you found this one, 9.8, you can actually use any of those other two. So we could use the one we found, or you could use the one that's already given, and you'll get the same thing. So you can test it if you'd like. So anyway, sine of 86 over 25 is equal to sine of 71 over y, and then you'll get y times sine of 86 is equal to 25 times sine of 71. Y is equal to 25 times sine of 71 over sine of 86. And then when you put that in your calculator, you'll get that y is equal to 23.7 feet. And that's it. So again, this here, I mean, law of sines should be reviewed, but if it wasn't, hopefully it wasn't too bad. So why does it come back, and why are we reviewing it? That's because in our curriculum we cover the ambiguous case. Okay, in Math 2 or geometry, you don't cover ambiguous case. It's pretty basic, like the ones we just did. But the problem is that sometimes when finding angles, it's possible to have one solution, two solutions, or no solutions. That's what the ambiguous case is. Okay. Some important facts, things that we've seen now thanks to our unit circle lesson. The sine function always has a range between -1 and 1. Okay, and what I mean by that, think about it, like all the values we've taken when we use the sine function, they're all between, they can go as high as 1, right? And if you go along the unit circle, I don't have the unit circle handy, right? But it goes, you have sine of 0, which is 0, and then you're gonna have, you're gonna have the various measures here. You got 1/2. You can have radical 2/2. So here's radical 2/2, right? 0.707. You have radical 3 divided by 2, 0.86, and then you're gonna keep getting closer and closer, and then finally, when you get the sine of 90 degrees or the sine of pi/2, you get to 1, and then you're in the second quadrant, and it's gonna start declining all the way back to 0. So, yeah. The sine function always has a range between -1 and 1. If the sine function is positive, then the angle can lie in quadrant 1 or 2, right? Because those are the first two quadrants where sine is positive. After that, you're in the negative y-axis, so then the sine function will be negative. To find the other possible angle, for the sake of these problems, you're going to subtract from 180. And then the sum of the angle measures in a triangle is always, we know this also, right? It's always going to be 180 degrees. And recall from geometry, no triangle can have two obtuse angles. And this is, just a handy piece of logic here to being able to figure out what my solutions are. So for number 7, well, for all these problems, you're going to have information given about triangle ABC. And then it says check your answers and give all possibilities. So this is the way these work. So if you ask me, I'm one who just has to draw out everything. You're gonna have just draw your arbitrary triangle. I have triangle A, B, C. It says the measure of angle A is 50, so there's 50, and it says AB is 4. So there's AB, and then BC is 9, and it says find the measure of angle C, so find this guy there, X. So law of sines, I can use sine of 50 over 9 is equal to the sine of X over 4. And then this time I'm going to be using the inverse trig function, right, because I'm finding an angle measure. But anyway, I have, let me see, I would have that the sine of x, is equal to 4 times sine of 50 over 9, right? I multiply both sides by 4, so I get this. So then you would take, yeah, you could just go ahead and do this, and then you would take the inverse angle measure. So 4 times sine of 50, let me see, because I did a little different here on my side notes here, but you should still get the same thing. So I'm getting this. That's what sine of x is equal to. And then right here, 0.34. And then you would take the inverse sine of, and you could just, I would type in as many decimals as you can put in here for the sake of accuracy. Close it, and you're gonna get about 19.9. Okay, so 19.9 degrees. X is equal to 19.9 degrees. Okay, the way I did it in my side notes here, I multiplied both sides by 9 too, and then I found what 4 times sine of 50 was, and then you get the same thing. So yeah, I don't know why. Anyway, so you get 19.9 degrees. What you do now is you subtract this from 180, right? And then you find your other possible solution. So if I subtract this from 180, you're going to get 160.1 degrees. But there's a problem, so this is how you check your solutions, okay? Check your answers and give all possibilities. We had one given angle of 50 degrees. 50 plus 19.9 is clearly less than 180, right? but 50 plus 160.1 is greater than 180. So this one here does not work. Okay, so then this particular problem only has one solution, 19.9 degrees. Number 8, again, draw out the triangle ABC. This is the measure of angle A, a measure of angle B is 37. It says AB is 47, AC is 29, and it says find measure of angle C. So this guy. So sine of 37 over 29 is equal to the sine of x over 47. So I get sine of x is equal to 47 times sine 37 over 29, right? I multiply both sides by 47. So put this in your calculator. You're going to get that the sine of x is equal to let's see, I'll write it out for this one. So when you put this in your calculator, you're going to get that sine of x is equal to 0.9754, and then take the inverse function, and then you're going to get that the x is equal to 77.3 degrees. If you subtract this from 180, you're going to get 102.7 degrees. So if you check both of these with the one that was given to us, 37 degrees, you can see that 37 plus 77.3 is less than 180, and then this time 37 plus 102.7 is also less than 180. So they both work, right? So then in this case, both of these will be solutions. Number 9, let's see. Draw out this guy. Got ABC. Measure of angle C is 75. AB is 28. AC is 19. And says find measure of angle B. So sine of 75 over 28 is equal to sine of x over 19. So sine of x is equal to 19 times sine of 75 over 28, right? I multiply both sides by 19 to get this. And then when you put this in your calculator, you're going to get that the sine of x is equal to 0.6554. Take the inverse sine, and you're going to get that sine of that x, the angle, would be 41 degrees. If you subtract that from 180, you're going to get 139. So check, right? The one that was given was 75. If you add 41, that's less than 180. If you do 75 plus 139, though, that's greater than 180. So only one works. That would be this one here, 41 degrees, excuse me. So next one, that was embarrassing, sorry. ABC, the measure of angle A is 114. AB is 34, BC is 12, and it says find measure of angle C. So the sine of 114 is over 12 is equal to the sine of x over 34. Sine of x is equal to 34 times sine of 114 over 12. This expression in your calculator is going to give you it gives you 2.5884. Now find the inverse function of this, but you might pause and be like, wait a minute, there's a problem here. Look, 2.5884. And we already know that the sine function only has a range between -1 and 1. So it's going to be greater. You can try putting this in your calculator, but it's going to give you an error. So this one has no solution. Okay, it's not possible. In other words, this triangle is not possible. So next one, here's A, B, C. Measure of angle B is 47. AB is 33. AC is 26. And then it says find the measure of angle A. This one here. So this time, right, I'm not using one of the sides that they're giving me. So this one, sloppy, is 26. Yeah. So I'm not using one of the sides I was given. No, sorry, it was this one right here. I'm not using that one, and I want to find this angle. So my approach for this one, I could do sine of, I'm using sine of 47 over 26 for sure, right? I have two. I call this one Y. I call angle C Y for now, so I can find this guy first and then go from there. So sine of Y is equal to 33, right? And then from here I can find angle Y. Sorry, yeah, I can find angle Y using solving this. So I get 30 sine of Y is equal to 33 times sine 47 over 26. So sine of Y, if you put this in your calculator, you're going to get 0.9283. So then angle Y, you're going to get 68.2 and then 111.8. Alright, so I can check based on the one that's given here, 47 plus 68.2, that's clearly less than 180, and then 111.8 plus 47 is also less than 180. So both of these would have been are solutions if I was finding angle Y, but I'm trying to find angle X or angle A, right? So, but I'm going to use these two possible solutions for Y to be able to find X. So how would I go about it? X also has two possible solutions, right? 180 minus 47 degrees, because that's the one that's given, minus this one because it's a possible solution for Y as well. So this would be plus 68.2, right? You add these two up and you get one possible solution. You're going to get 64.8 degrees. So that's one possible solution for X. The other one is 180 minus 47. This time we take this one, so plus 111.8, and you're going to get that is 21.2 degrees. And then that's the other solution. So that's it. So this one does have two solutions. Number 12. I have A, B, C. It says measure of angle C is 73. AB is 8. BC is 17. And then it says find the measure of angle B. So I'm going to call that one X. So similar approach, right? They want angle B here, but that side's not given, so it's going to have similar approach to this. I'm going to need to start with the measure of angle Y and then go from there. So sine of 73 over 8 is equal to the sine of Y over 17. So then the sine of Y is equal to 17 times sine of 73 over 8. And then when you put this in your calculators, you're going to get the sine of Y is equal to 2.0321. So then there's a problem, right? Look, again, you can try to find the inverse here, see what the angle is, but it's a greater than 2. And that means just like this one up here, right, where it was 2.5, there was no solution. So that means that the angle Y here has no possible angle measure either. It's not a possible triangle. So that means you stop right there. There's no solution. And that's all there is to this concept regarding law of sines. So show the last problem again. So hopefully it wasn't too bad, and of course ask me questions if you guys need help.